Good morning, students. Today we'll start with the new chapter, that is chapter 9, direct variation and inverse variation. So before going to the chapter, let us learn what is variation. Now, see here, when there is a change in one quantity, there is a change in the other quantity. Such changes are called as a variation. For example, if you buy 2 pens from the shop and you are paying 10 rupees. In the same place, if you are buying 4 pens, you have to pay 20 rupees. So, number of pens 2 and this is 10 rupees. When number of pen increased 4 pence, then also cost also increase. So such changes, when there is change in one quantity, there is change in another quantity. Such changes are called variations. Such changes are called variations. So when there is a change in one quantity, then there is a change in another quantity. Such a change is called variation. In variation, there are two types of variation. One is direct variation, the other one is inverse variation. Now, for type direct variation, when there is an increase in one quantity, then there is also an increase in another quantity. This is direct variation. Such changes is a direct variation. When there is increase in one quantity, the other quantity also increases. Such a change is called as a direct variation. For example, you can see in your textbook page number 63. See, some circles are marked of the same radius. Some circles, 4 circles are given of the same radius. In the first figure, you can see one diameter is drawn. Means the circle is divided into by one diameter. Then 2 diameters are drawn. Then the circles. In the first figure, the circle is divided into 2 parts. In the second figure, when 2 diameters are drawn, then the circle is divided into 4 parts. Again, if 3 diameters are drawn, then the circle is divided into 1, 2, 3 into 6 parts. Even again, when 4 diameters are drawn, then the circle is divided into 8 parts. So you can see when the number of diameters increase, the number of parts in the circle also increased. So when one quantity increases, the other quantity also increases. Such a change is called direct variation. So this is an example of direct variation. Now, so look at another another example here. See, number of notebooks that the students of a government school received is shown in the table below here. Number of children and the notebooks. 15 children are there, 90 notebooks. If 12 children are there, 72 notebooks. So first the more children were there, then it became 12. So the number of children decreased, the number of notebooks also decreased. Then if 10 children are there, then 60 notebooks. Again, number of children decrease, the number of notebooks also decrease. If 5 children are there, then 30 notebooks. Again, number of children decrease, so number of notebooks also decreased. So this is an example of direct variation. So number of children upon number of notebooks. You can see this ratio as see 15 by 90, 12 by 72. 15 by 90, 12 by 72, then 10 by 60, the ratio of it 5 by 30. You can see 15 ones are 15 6 is 90, 12 ones are 12 6 is 72, 10 ones are 10 6 are 60, 5 ones are 5 6 are 30. All you have the ratio as 1 by 6, 1 by 6, 1 by 6. So in direct variations, always the ratio of the two quantities are constant. So in direct variation, the ratio of the two quantities are constant. So in direct variation, the ratio of two quantities is the ratio of the two quantities are always constant. Are always constant. Example, I will give another example. Here, number of pens and cost of pens. Cost of pens. 2 pens cost 10 rupees. Then 5 pens will cost 25 rupees. 6 pens will cost 30 rupees. Because 1 pen costs here 5 rupees. So 5 6 are 30. 8 pens will cost 40 rupees. 10 pens will cost 50 rupees and so on. You can see the ratio of this. Ratio of this, that is 2 by 10. 5 by 25. Then 6 by 30. 8 by 40. 10 by 50. 2 ones are 2, 2 fives are 10. It is 1 by 5. Yes. 5 ones are 5 fives are 25. 1 by 5. 6 ones are 6 fives are 30. 1 by 5. 8 ones are 8. 8 fives are 40. 1 by 5. 10 ones are 10. 10 fives are 50. 1 by 5. So we are getting all the ratios as 1 by 5, 1 by 5, 1 by 5. So this table is an example of this table is an example of direct variation. So this is what you learnt about direct variation. The second one is inverse variation. Inverse variation. Variation. In inverse variation, it is just the opposite of this. See, when here in direct variation, when there is an increase in one quantity, then there is also an increase in another quantity. But here, when there is in inverse variation, when there is an increase in one quantity, then there is a decrease in another quantity. Decrease in another quantity. Such change. So this is direct variation. This is inverse variation. Inverse variation. For example, suppose if I take an example of number of men's and the work and the number of days required for them to do the work. So, number of men and number of days required. Number of days, alright. That is number of days required to do the same work. If suppose same work is there. Same work, it has to be done, but 12 men's 12 men can do the work in 5 days, suppose. Then the same work, 2 men will do it in 30 days. Then 4 men will do it in 15 days. And 10 men will do it in 6 days. The same work is given. If 12 men are required to complete the work in 5, they will complete the work in 5 days. Thus, if same work is given to only 2 men, then they will complete in 30 days. And if the same work is given for 4 men to do, they will complete in 15 days. And the same work by 10 men, it can be completed by 6 days. So you can see here the product of the quantities. Product of quantities is constant here. Product of quantities, that is 12 into 5 equal to 60. Then 2 into 30 is equal to 60. 4 into 15, 60. Then you have again 10 into 6 is equal to 60. So you can see the product of the two quantities is constant. So in inverse variation, the product of the two quantities is constant. So product of two quantities is always constant. Always constant. So this is about the inverse variation. I have given one example of direct variation and an example of inverse variation. So what is variation? When there is a change in one quantity, there is changes in another quantity. Such changes are called as variations. We have two types of variation, direct variation and inverse variation. In direct variation, when one quantity increases, then there is an increase in the other quantity also. Example I have given here. And the ratio of the two quantities is always constant in direct variation. But in inverse variation, when there is an increase in one quantity, there is a decrease in the other quantity. So this is a inverse variation. You can see in this example here, the product of the quantities is always constant. So in inverse variation, the product of the two quantities is always constant. So this is about in direct variation and inverse variation. Now let us solve for practice set 37. I have taken fifth question first, then I have taken third question because this third question is little bit more little complicated more than the fifth one. The fifth one is more easier one and the remaining also are easier. Remaining you have to solve by yourself. Now see here, two mobiles cost 16,000. How much money will be required to buy 13 such mobiles? So, to buy two mobiles you need 16,000. To buy 13 mobiles you need more money. So, when number of mobiles increase, the cost also will increase. So, when there is increase in one quantity, there is increase in other quantity also. So, this is an example of direct variation. So, here, this is an example of direct variation. So, we know that in direct variation, we know that the ratio is constant. So, in direct variation, indirect variation, ratio is constant. Therefore, this you have tried for every sum is constant. Therefore, we have, see, two mobiles here, mobile and first mobile upon cost. So here, two mobiles cost how much? 16,000. This will be equal to 13 mobiles will cost how much? We don't know the amount of 13 mobiles. So let us take this as X. So we have got two equal ratios. 2 by 16,000 is equal to 13 by X. So when we have these two equal ratios, we can solve it by cross product. 2 into X this way. 2 into X is equal to 13 into 16,000. So X is equal to this 2, you bring this side, it gets divided by 13 into 16,000. 16,000 divided by 2. So 2 ones are 2 8s are 16 and this 0 0 0 will remain. So X is equal to as 13 into 8. And that will give you as 0 0 0. 3 8s is 24, carry 2, 3 8 1 8 9 10. So it is 1,04,000. Therefore, cost of 13 mobiles is 1,04,000 rupees. So we have solved the fifth question using the method of direct variation, ratios constant. So here also let us come with this example. For 9 cows, third question, for 9 cows 13 kg 500 grams of food supplement are required. For 9 cows 13 kg 500 grams of food is required every day. In the same proportion, how much will be needed for 12 cows? So you know, see, number of cows will increase, means the food also will increase. So there is increase in one quantity, there is increase in other quantity also. So this is an example of direct variation. So again, this is an example of direct variation. Direct variation. Therefore, in direct variation we know, in direct variation the ratio is constant. Ratio is constant. Therefore, we'll form the ratio, that is number of cows by food, that is quantity of food. Okay. So, if there for 9 cows 13 kg 500 grams is needed, then in the same proportion how much will be needed for 12 cows? This is equal to 12 cows, how much food is required? First of all, we'll change the 13 kg 500 grams is equal to as only grams, that is 13,500 grams. We'll take in this form. So it is now 9 by 13,500 is equal to 12 by X, equal ratios. As we solve this by cross product, in the same manner this one also will solve it by cross product. So cross multiply 9 into X is equal to as 12 into 13,500. So X you leave it here, X is equal to 12 into 13,500 divided by 9. Now 12 and 9 is cancelable. 3 threes are 9, 3 fours are is 12. Again this number and this number is the cancelable. 3 ones are 3, 3 fours are is 12, 13, 1 extra that you will write here. So 1 and 5 will make you 15. So 3 5s are, we have to read the multiples of 3 here. Table of 3. 3 4s are 12, 1 extra here, put it here. So it is 15 now. 3 5s is 15 and these two extra zeros. So x is equal to as 4 is left here into 4500 is left. So x is equal to as, multiply this 0 0 4 5 are 20, carry 2 4 4 are 60 70 80, 18,000. Therefore 12 cows needs 18 kg, 18,000 grams, it is grams. So therefore 18 kg of food is needed for 12 cows. So this, in this way we use the property of derivative variation and solve the sums.